My teachable student, I welcome you back to our special class where we present the simplicity of the science subjects. I want to believe you are following the teaching. If today is the first time of coming across our video, I will advise you to go back to our previous videos to watch how I solve the problem we have in example 1, in example 2, and in example 3. You can even watch the teachings that come before the problem we have in example 1. All right, so we also have a WhatsApp group where we share ideas on how to solve problems that are related to science subject. If you're interested, you can just go to the comment section, click on the link to join us. All right, so I want to believe again that you are following the teaching and you understand how I solve the problem that we have in example 1, in example 2, and in example 3 using SOHCAHTOA. Do not forget, I said SOHCAHTOA is not a formula, but it's just a procedure, an order or arrangement to be followed in solving basic trigonometric ratio, which are sine, cosine, and tangents. All right. So today I will be moving away from the use of SOHCAHTOA to the use of Pythagoras theorem. Now, Pythagoras theorem deals with the side of the right angle triangle only with respect to the hypotenuse side. So when it comes to writing out the formula of the Pythagoras theorem, it starts with the hypotenuse first. That becomes the subject of the formula. So it will be hypotenuse square is equal to the sum of the squares of the adjacent side. Do not forget, from the beginning of this class, I said when it comes to right angle triangle, the naming, we have the hypotenuse side and the other two sides are the adjacent side. Again, when it comes to right angle triangle, we have the hypotenuse side and the other two sides are what? The adjacent side. And I said one of the two adjacent sides can change them to opposite side and the other one remain adjacent side, or this one change to opposite side and the other one remain what? Adjacent side, depending on the position of the given angle. All right, so here under Pythagoras theorem we only focus on the hypotenuse. All right, so to be hypotenuse square, or the square of the hypotenuse is equal to the square of adjacent side plus the square of the second adjacent side. Again, it will be square of the hypotenuse side is equal to the square of the adjacent side plus the square of the second adjacent side. So you discover that the hypotenuse side, it happens to be the subject of the formula. All right, though if you like, write the formula this way: the square of the hypotenuse side is equal to the square of the opposite side plus the square of the adjacent side. Okay, again, square of the hypotenuse side is equal to square of the opposite side plus the square of the adjacent side. I hope that one is very clear. So it is used, Pythagoras theorem, it is used to find the third side of a right angle triangle provided the two other sides are given. Okay, so if you are given two sides of the right angle triangle, to find the third side you make use of the Pythagoras theorem. Again, if you are given two sides of the right angle triangle and you are asked to find the third side, you make use of the Pythagoras theorem to find the third side. I hope that one is very clear. It's not difficult. So Pythagoras theorem too is very useful only when you are dealing with problems that are related with right angled triangle. Is that one clear? All right. The diagram we have here, you will discover that the hypotenuse side is the small letter C and the two adjacent sides are A and B. Now, do not forget, I said we use small letters to represent sides and the capital letters to represent angles. And I said each side is facing a unique angle. Alright, so now from the formula of the Pythagoras theorem that says the hypotenuse square or the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent side. Alright, so we have it on the page here that c square, that c is the hypotenuse side, is equal to a square plus b square. So that a and b represent the adjacent side, or you can take one as opposite and the other as what? Adjacent. So we have c square is equal to a square plus b square. Do not forget, I said the formula is used, I mean the Pythagoras theorem, to find the third side when any two sides are given. So now look at this example 4. Calculate the value of x. If you look at the diagram here, there are two right angle triangles. And I told you then, previous example, that when you have a shape that has two or more triangles joined together, okay, that after splitting them, there will be a common side. Alright, so here the common side in this shape after splitting the triangle is line AC. Alright, is what? Line AC. So in splitting it, you have line AC in the first right angle triangle, then you have line AC in the second right angle triangle. So I bring in letter Y to represent the common side. Okay, so now what you're looking for is letter X, but you cannot find the letter X without finding the common side. I told you the common side is very important. Okay, so without finding the value of the common side, then we can't find the value of the X. So to find the value of the common side, now look at the two right angle triangle. You will discover that in the first right angle triangle, they give us two sides. First right angle triangle. In finding the value of the third side, that is Pythagoras theorem, which says that hypotenuse square is equal to opposite square plus adjacent square. So our hypotenuse here is y. Y is facing this right angle. Okay, so y is the hypotenuse because it's facing the right angle. So we have y square is equal to 9 square plus 12 square. Okay, there are square on the formula. So the 9 square is for one of the adjacent side and the 12 square for the second adjacent side. Though I said you can take one as the opposite and the second one as the adjacent. Do you get that now? Okay, so the value of 9 square is 81 and the value of 12 square is 144. So when you add your 81 and 144, it gives us 225. That is for y square. Now, if you are going to find the value of y, because from diagram what you have is y and not y square. So to find the value of y, you have to remove that square. Now, to remove square, you need square root. Square root cancels square, and square cancels square root. So if you have square and you want to cancel that square, you introduce square roots. And if you have square root and you want to cancel that square root, you introduce square. So here, because we have square and we want to cancel that square, we introduce square root. So we take square root on both sides. So square root on y square, square root on 225. Whatever you do on one side, you do the same thing on the other side. So the square root will cancel square. We are left with y now. And the square root of 225 is 15 in centimeter. You can use calculator for that. If you are doubting the value, the calculator will give you the answer. That will be 15 centimeter. So we succeeded in getting the value of the common side. And that will help us now to find the value of x. So take that y to the second right angle triangle. Okay, by doing that, it means we have two values on the second right angle triangle, which are the 8 centimeter that we have there before, and the value of y, which is what? 15 centimeter. So now we have two values on the second right angle triangle. So we can now use Pythagoras theorem to find the third side. And luckily again, the third side here is the hypotenuse. Our x is hypotenuse, y is facing the right angle. Okay, so from the formula we have here, hypotenuse square is equal to opposite square plus adjacent square. So our hypotenuse is x, to be x square, because there are squares in the formula like I said earlier. So to be x square plus y square plus a square. The value of y is what? 15. So you're going to have 15 square replacing that y plus what? 8 square. So the value of 15 square is 225, and the value of 8 square is 64. So when you add 225 plus 64, it gives you 289. Of course, what you're looking for is x, but there's a square on that x. So that square will have to leave. What do? You introduce square roots. So square root on x square, square root on 289. So that square root will cancel square. You are left with x. And the square root of 289 is 17 centimeter. So we succeeded in solving the problem we have in example 4. Is that one clear to you? So have it in mind that science subjects are the most simplest subjects. Okay, so from DFM Mike Mattis, I said goodbye and God bless. Bye for now.